I'm going to talk now about the analysis that was done of deep decarbonization in the United States. It was done by a team from E3, UC Berkeley, Lawrence Berkeley National Lab, and Pacific Northwest National Lab. Two reports have been produced, one called the technical report, one called the policy report, and together they asked the following questions. What would it take for the US to achieve an 80% greenhouse gas emission reduction below the 1990 level by the year 2050? Is it technically feasible? What would it cost? What physical changes are required? And what are the policy implications for the US? What was done for this analysis was the construction of different scenarios for different pathways, different ways that we might achieve these reductions by 2050 in order to achieve the targets. And these scenarios had some constraints in them. The first is that the energy system has infrastructure inertia. You don't just change things overnight. You have a stock of buildings, of vehicles, of power plants, and they're going to change over an extended period of time. That is all incorporated into our analysis. Electric reliability, we don't want to come up with a fantasy electricity system that wouldn't actually provide reliable electric power. So that is a technical constraint in the scenarios. The scenarios you'll see have the same energy services as the long-term government forecasts from the Energy Information Administration. What that means is people are basically consuming as much energy, or at least getting the same kinds of services out of energy that they're projected to right now. That is, you're living just as comfortably, you're getting as much transport as you want, you're able to wash your clothes, you're able to heat your house and so forth in a way that's very similar to what we do today. And the economy is as productive as what we anticipate under other circumstances. The question we asked was, can you achieve the same kind of economy and daily life that we have now under a deeply decarbonized system? The technology that was used is commercial or near commercial. That's to say it exists today and doesn't incorporate any technological miracles. And finally, there are reasonable environmental limits on what you can do. You can't use excessive amounts of biomass that will have other damaging effects on ecosystems. Similarly, there's great limits on how much hydroelectricity you could use. The work was done with something called the Pathways model, which is an energy system model with user-defined scenarios. It has 80 demand sectors and 20 supply sectors. It has a great deal of detail of all the stocks of energy supply and demand equipment. There's many different kinds of refrigerators and light bulbs and power plants and vehicles incorporated in this. And each one has its own lifetime that's typical and its own vintage. So if you have a 1995 vehicle right now, it's probably not going to last that much longer in this model because it's coming to the end of its lifetime. All 9 US Census divisions are separately modeled, and the electricity system, which is in 3 so-called interconnects or interconnected power systems in the United States, are all separately modeled. Again, this is by way of saying what we've done is create a representation of the United States in the way that uses energy that is very believable. We also used another model called GCAM from Pacific Northwest National Lab to model non-energy and non-CO2 emissions. So we have a very credible hybrid modeling approach done by national labs and energy experts to be able to model all the different kinds of greenhouse gas emissions from the United States and answer our question. So here's some high-level results. The first one is that an 80% reduction in greenhouse gases by 2050 in the United States is an achievable result. The second is that there are multiple feasible technology pathways. So you see on this slide what our current emissions are in the US, what our forecast emissions from the EIA are for the year 2050. And then the four very low levels of emissions are all different scenarios that reach per capita energy emissions of 1.7 tons per person in 2050. We built four scenarios, all of which reach the emissions goal that we have for the year 2050, reducing recent US per capita CO2 emissions by a factor of 10 below the present, while still providing all the energy services that our economy and our productivity require. And these four scenarios are all quite different. We refer to them as the high renewables case, the high nuclear case, the high carbon capture and storage case, and the mixed case. Those names refer to the kind of electricity system involved, but in fact, they're even more variable than that, because these cases also explore different kinds of transportation systems, different measures in industry, different kinds of building measures, and so forth. But for a shorthand, we refer to what the dominant part of their electricity mix is. And the point is, all four of these are able to achieve deep emissions reductions without hardships and consistent with realistic constraints about grid reliability and infrastructure inertia. Our current energy system, this is something called a Sankey diagram, is represented here. What it shows on the left-hand side is for 2014, primary energy is on the left. So you can see that that's dominated by very small amounts of renewable energy like geothermal and solar and wind, and very large amounts of fossil fuels like natural gas, coal, and petroleum. As you move from left to right in this diagram, the primary energy undergoes transformation to become the kind of energy that we actually use when we plug something into the wall or we put it into our vehicles or whatever. What I want you to notice is on the right-hand side, we've created three sort of mega end-use sectors: buildings, industry, and transportation. That's basically where energy goes for final consumption. And in the middle, you can see the kinds of transformations. Pay special attention to the blue line on top, which is electricity generation. So you can see different kinds of fuels going in and grid electricity coming out. Let's look at a deeply decarbonized energy system in 2050. This is one of our four scenarios called the mixed case. So one thing you'll note is on the left-hand side where we have primary energy, the renewable energies are much larger. Those lines are much thicker than they were in the current case. And the fossil fuel lines are much smaller, to the point where coal, which is really incompatible with a deeply decarbonized system, is basically non-existent. And the other fossil fuels, petroleum and natural gas, are greatly reduced. Meanwhile, that blue line that represents grid electricity is greatly expanded. And this gives you a hint as to how we go about achieving a deeply decarbonized energy system while still providing whatever the economy and our daily lives need.